We are going to look at page 4 of the qualitative analysis lab. And what we're going to look at is, get a little marker here. And we're going to make a test tube. I think I'm going to go back. We're going to look at this flow chart on page 4, but I'm going to go back here. It said you add your data table, and we're going to use that data table to complete a flow chart. And then what we're going to do is test to known. We're going to fill one test tube with 1 milliliter each of silver, barium, and zinc ions. And then we're going to follow the flow chart to make sure that we can separate the silver, barium, and zinc at the appropriate steps. So that's what we're going to look at here in this part of the lab. All right, so we're probably going to have to look at this flow chart. I'm not going to jot things in, but I am going to talk about what you need to do. And I think I'm just going to keep that up so you can see that. And then in one test tube, the procedure said to put 10 drops of silver, and then it said to put 10 drops of barium, and then it said to put 10 drops of zinc. Okay, if I look at this, it looks pretty clear. Okay, so this solution is pretty clear, and I can't really tell if it's got any ions, or if it's distilled water, or what it is. There's no visible evidence of what that is if I look at it real close right here. So what I'm going to do is follow this flow chart. The first thing I'm going to do is add Cl minus, okay, and then I'm going to mix it, centrifuge it, and decant it. All right, so I'm going to add my 10 drops here. So adding 10 drops. Now, sometimes it says in there to give it the knuckle, or you can mix it with your finger, but you want to wrap that around and mix it real good. And now it almost looks like, it almost looks like chunks in there of, I don't know, like cottage cheese or something that's kind of sinking to the bottom. So what happens is, if I add the Cl minus and mix it, now I want that to separate better. Okay, so what I'm going to do is centrifuge it. So I'm going to put it in this spinning thing here, and I'm going to get a blank. So, because I can't just put one test tube in the centrifuge, I'm going to fill someone with water up to about the same amount. So it's got about the same mass. I'm going to put them across from each other in a centrifuge. I don't think you can see that from where you are. So I'm going to tilt this down. So I have a centrifuge right here. And this is my silver chloride right here. And this is just a blank with water. And the only reason I'm doing the blank is because I want to keep it balanced when I do this. Now, if somebody else had their unknown and it was labeled well, I could do that. I turn that on. This one doesn't have a hood. It's moving really, really fast. And sometimes those test tubes have a chip on the outside. You don't want your finger to go in there. If it catches that, it could cut that. And the blood would go in the test tube. It would interfere with the results, and it wouldn't be safe. Okay, now I shouldn't put my hands up here, but I'm professionally trained to put it way on the side, so there's no way my fingers can get touched. I can move that. I can stop that a little bit more quickly. So here's the blank test tube. And here's the test tube with the silver. It probably is a silver combining with a chloride. I'm guessing it's silver chloride. Notice because it was angled, it all went kind of down to the bottom and to the side of the test tube. Now, what's cool about this is I'm assuming the silver chloride is gone. So that's actually going into this box right here. This is the precipitate. This is the Ag+, because that is the only ion that reacts with Cl minus. And then the barium and the zinc remain in the solution. So barium and zinc would go in these two spots. So what I can do is just separate these by decanting better grab a test tube that is clean and clear. And I'm going to pour this off. And notice this is a clear solution here, which has the barium and the zinc, and then the silver is left behind with the silver chloride. So in my test tube, I might say, oh yeah, this is a white precipitate. This is a silver ion right here. And then I have barium and zinc right here. So now I can scroll down my table a little bit. Whoops, I scrolled a little too far, too fast. Getting different numbers here, kind of at some interesting angle. All right, now it says add FeCN6 minus 4. So that's kind of my next step in this flow chart. Oops, went back to the beginning. I think we're okay there. So we narrowed it down to silver is over here, barium and zinc are over here. And what I'm going to do is go right to my solution part from this and add the FeCN6 minus 4. And I'm going to drop that in. It looks kind of cloudy as I'm adding the drops. If it gets cloudy as you add the drop, that's a pretty good sign there is a precipitate. Notice it's a little different when it gets mixed with other stuff than what it might have looked like before, but it's kind of that whitish, dingy, yellowish precipitate right here. And it looks, at least it looks all cloudy, and I'm going to try to separate that out again. So I added this, it looked like it got cloudy. I'm guessing I have a precipitate, and then something's remaining in solution. Now, if you look back at your data table from last time, you'll probably able to reason this out. Put it in the centrifuge here. Put these on opposite sides of the centrifuge and give that a spin. All right. And my thinking is that when I added that FeCN6 minus 4, I think the barium didn't do anything. It remained in solution, where the zinc turned into a precipitate, a white precipitate. So I'm going to scroll down a little further here. Add this in. I think we've spun that a while. And this is our blank solution, which is clear. That was just a balance. And then notice, oh yeah, it's kind of some fluffy precipitate on the bottom, but then that solution part is really clear. So now I look at my data table and says, oh, with FeCN minus 6, barium doesn't form a precipitate, so that must be in the solution. But the zinc forms a precipitate, so that must be here. Now the silver also forms a precipitate, but we got rid of that a while ago. So the silver is gone, so we don't have to worry about that here. We got rid of it. So you don't worry about the silver anymore, it's gone. So this zinc would be the precipitate here, that white fluffy precipitate. And then what we have left here in the solution would be barium, I think. We want to make sure it's not just distilled water. So I'm going to do a test with that. I'm going to decant the liquid, which would contain the barium, into one test tube here. And then I'm going to keep the solid, and that would be the zinc compound that I formed there. So now I'm going to add CrO4 minus and mix. And my guess is I'm going to get a precipitate. Let's see where we're at. Because I think barium forms a yellow precipitate when I mix it with CrO4 minus 2. So let's go ahead and do that. Add the CrO4 minus 2, get rid of my centrifuge, and 1, 2, oh yeah, it's getting cloudy right away as I add the drops. Holy precipitation, Batman. Look at that. Okay, so it's getting cloudy. And again, I'm gonna mix this fingers or the knuckle, and if I spun this around, that solid would sink to the bottom. You don't have to do that here. I guess we could if we wanted to, so maybe I will. But this should be the barium or barium chromate precipitate right there. And we can see that sink to the bottom if I put that in right here. All right, so I'm just going to do that. Give it a little spin, put it around opposites, and there we have it. So that's spinning, and again, the heavier stuff goes to the outside, which is a precipitate. It's kind of at an angle, so that's why you see it coming out at an angle. And I don't know if that was long enough. Slow this up, and let's see what we have. We have our blank, and there is the precipitate kind of stuck down on the bottom there, okay, in a solution. So it's a yellow solution, whitish yellow precipitate. On the bottom would be that barium chromate right there. Okay, and we saw how cloudy it was when it went in there. So that would be our separation of things. Now, when you do an unknown, you might not see a precipitate here. Then it's like, what does that mean? It doesn't tell you anything about silver and lead or silver and zinc. It tells you you don't have barium right here. If you do this step and you don't get a precipitate, it's telling you, oh, I don't have, what did we say was here, was zinc. If you do that first step and you don't get a precipitate, it's not telling you what you do have. It would be telling you you don't have silver. So going through this, you add the Cl minus. The first precipitate you got was a white silver precipitate. Ba and Zn remained in solution. Then you added this FeSC or FeCN6, and the precipitate was the zinc with that. The Ba remained in solution, and then you added CrO4 minus 2, and the Ba precipitated and formed a precipitate right here. So you're able to sequentially take one thing and get each different precipitate and separate that out. All right, thanks for watching.